Morning, guys. We are going to start our next section, which is a big and important section. It's integration by substitution, and we're going to really take our time with this. It's gonna if I scroll down this note sheet, you can see all of the different examples that there are. I'm going to break this down into really small chunks. It's an important topic to learn, and I want to make sure that we have a good understanding of this. So I'm really going to chunk it up into smaller segments. Normally, this probably be in class, probably like 2 to 3 days. So obviously, imagine we're going to expand that a little bit here. The goal here is to make sure you actually understand the material. All right. So you probably won't be having another assessment for over a week, I would say. All right. So, so we are going to be integrating, okay, and we are going to be using substitution. All right. So, if I look at this first integral, I know my integral symbol is a little messed up here from the PDF, but if we had something like this, the only way we know how to do that right now is we can't use the power rule. All right. We had to actually multiply all of this out. So you would have to make this like 25x squared plus 30x, and then you would do plus 9, and then you would integrate that from there, which would be what? 25x cubed over 3 plus 30x squared over 2 plus 9x. Well, what happens if I had, instead of being 5x plus 3 squared, what if it was 5x plus 3 to like the 8th power? Well, we're not going to multiply out 5x plus 3 times 5x plus 3 times 5x plus 3 plus yada, yada, yada. All right, so there has to be a better way for us to do it. We cannot do the power rule. All right, if you try to do the power rule of 5x plus 3 cubed over 3, it does not work. All right, so we cannot use the power rule. So what we're going to do is something called substitution. All right, and what we're going to do is pick our u. All right, we're going to do u and du. We're going to be doing a lot of this over the next couple months. All right, now the inside is going to be our u. All right, our du is going to be the derivative of u. Okay, now what I mean the inside, for right now to start, the inside is exactly what you think it's going to be. So for this particular problem, obviously you can do it this way, but if we're going to do this by substitution, the inside is whatever you have a quantity raised to a power. So from now on, whenever we have a quantity, meaning whatever's in the parentheses, raised to a power, we're going to do substitution. Whatever is inside the parentheses is going to be our inside. It's going to be our u. All right. So our u is going to be 5x plus 3. All right. So that's where we're going to start off. Whatever's on the inside, that's going to be our u. That's where we're going to write it. Then, as soon as you write your u, we're going to write our du, which stands for the derivative of u. All right. So what's the derivative of 5x? Well, it's 5. 3 is just 0. And since we took the derivative with respect to x, we're just going to put a dx after it. All right. So we have our u is 5x plus 3. Our du is 5 dx. All right. So now what we are going to do is I want to rewrite this integral, and I want to substitute and rewrite all of this using du and u. All right. If I can't, that means I picked the wrong thing. So what is 5x plus 3? Well, that is what? 5x plus 3 is just u. So that's going to be u squared. Now, dx, I need to have all of this du needs to be here somewhere. All right, there's my dx. What am I missing? I'm missing a 5. All right, I don't have a 5 in here. So in order for me to rewrite and put a du here, this is what I want to be able to put. I want to be able to du. But du is 5 dx. I have a dx. I'm missing a 5. Now, fortunately, you are allowed to just add in a 5. You can add in constants. And at the top of the sheet, it says you may add constants into any integral as long as you compensate and multiply by the reciprocal on the outside. you cannot put in variables, only constants. All right, and you'll hear me say this a bunch. So I'm allowed to add in this 5 here. But if you put a 5 in there, that means I need to put a 1/5 on the outside to balance it out. All right. So this right here, this 5 dx, that's du. So I'm replacing all of this, gets replaced there. The 5x plus 3 squared is u squared. And I put the 1/5 on the outside because I put a 5 there, the 5 dx. So now this is something that we can integrate. All right, the integral of u squared, so I have 1/5 on the outside. U squared is just u cubed, we just do the power rule, over 3. All right, it's u cubed over 3. And now what we're going to do is substitute in our, so this is really u cubed over what, 15? But what was our u? Our u was 5x plus 3. So I substituted back in to write my final answer of 5x plus 3 cubed over 15. And then I'm going to write plus c. And there's my answer. 5x plus 3 cubed over 15 plus c. So now, I mean, obviously, since it's squared, if you wanted to multiply this out and do it that way, that's fine. A lot of you would do it that way. The problem is you're going to have problems like we get going through with example 2 and example 3, where you get bigger exponents. And we're not going to want to multiply all this out. All right. So the only way and the best way to do it is to do this with u and du. So we have a quantity being raised to a power. All right. So we make the inside is our u. So I get u equals 7x minus 1. You then take the derivative of that. The derivative of 7x is 7. Then I throw a dx. Okay. Now, my recommendation would be once you get to this, your first step is to make sure all of du has to be in the problem. So all of this has to be somewhere in the integral. Dx is right here. We're good there. What am I missing? There's no 7. This 7 does not count for this because this 7x minus 1 is all together, and that's going to be our u in a second. So I need to add in the 7. So if I add in that 7 dx, that purple thing is my du. All right. Right here, the 7x minus 1, that is my u. U to the what? It's u to the 4th. Now, you can't just put a constant in without compensating it for it on the outside. So since I put a 7 here, I need to put a 1/7 on the outside. All right. So once again, we need to make sure all of du has to be in the problem. All right. So 7 dx, I had a dx, I'm good there. I needed a 7. I added the 7 there is why I put the 1/7. So all of this becomes your du. The 7x minus 1 is your u to the 4th. All right. So we always had dx after the problem because that means I'm integrating with respect to x. I have du because now I'm integrating with respect to u. All right. So now we just do our power rule, 1/7 times u to the 5th over 5 plus c, which is u to the 5th over 35. And now I just go and replace my u. The u is 7x minus 1. So 7x minus 1 to the 5th over 35 plus c. All right, and there's your answer. All right. All right, so let's take a look at number 3. All right, so right now, I want you guys to first figure out what do you think your u should be. All right. Hopefully you got that your u is whatever's on the inside, which in this case is 2x plus 7. All right, now figure out what you should write for du. All right, hopefully you guys got 2 dx. All right, so now what you have to do is we have to rewrite our integral. Okay, this has to be all located somewhere in here. I have my dx. I'm missing a 2, so I need to add a 2 in. All right? All right, it's like adding a 2 to the front, to the back. It doesn't make a difference. All right, so since I put a 2 in there, I got to compensate and put the 1/2 on the outside. So I'm going to have the integral. Now I replaced all of this is now gone with du. So what's left is 2x plus 7. Well, what's 2x plus 7? 2x plus 7 is our u. So it's u to the 5th. All right, so 1/2 integral u to the 5th du, and then integrate 1/5 u to the 6th over 6 plus c. So I get u, which is 2x plus 7 to the 6th power over 2 times 6, which is 12, plus c. All right, so hopefully you are starting little by little to get the hang of this a little bit. All right, why don't you guys go ahead and try to get number 4. All right, so let's see how you did. U is going to be whatever's on the inside, 6x minus 2. Our du is going to be 6 dx. All right. So I have to make sure that all of this is inside here. I don't have a 6, so I have to add it in. Say there was a 6 out in front here, which sometimes there would be. Then you wouldn't have to add anything. All right, but since I do have to put a 6 there to make this du, that's my du. It means on the outside, I need to put a 1, 6 to balance that out, right? Because I can put that out on the outside, but if I multiply 1, 6, remember, any constant could always be moved to the outside. So 6 times 1, 6 is just 1. It's like you added nothing. Then this is u, so it's u to the 11th. And I get 1, 6 times u to the 12th over 12 plus c. So my final answer is 6x minus 2 to the 12th over 6 times 12. What is 6 times 12? 6 times 12 is 72 plus c. 6x minus 2 to the 12th power over 72 plus c. So hopefully you guys were able to get that, or at least pretty close to it. All right, we're just going to do a couple more. All right. Now, what's a little different for number 5? This can be rewritten. Remember, the square root is really 3x plus 1 to the 1/2. So what is our inside? Our inside is still 3x plus 1. That's on the inside of the square root. If I rewrote it this way, it's on the inside of the parentheses. So our u is going to be 3x plus 1. Our du is going to be 3 dx. All right. We then try to make sure all of this is in there. We're missing a 3, so I add in the 3. I rewrite the 1/3 on the outside. So instead of writing as the square root of u, I'm going to rewrite this because our du is 3 dx is right there. I'm going to write this as u to the 1/2. All right, it's a pretty big u there. The reason is because if I wrote it as a square root of u, you wouldn't be wrong, but then to integrate it, you would have to make u to the 1/2 anyway. All right, so now we're going to do our power rule, and I get 1/3 times u to the 3/2. All right, but I got to take the reciprocal of this. So the 2 goes on top, the 3 goes on the bottom. All right, so that's actually 2 u to the 3/2 over 9 plus c. All right, so my final answer is 2. U gets replaced with the 3x plus 1. And you don't have to make this into a radical. Just leave it to the 3/2 over 9 plus c. All right. Now, last one. We're going to skip 6. I'll start with 6 the next lesson as a review. But I want to show you number 7. Okay. So we got the integral of 3x squared, fifth root of x cubed minus 1. Now, don't worry about this right now. The only thing you care about is what's on the inside. Remember, this really means x cubed minus 1 to the 1/5. All right, x cubed minus 1 to the 1/5. So our inside for this problem is x cubed minus 1. Okay, now do our du. What is the derivative of x cubed? It's 3x squared. 1 is 0. It's a dx. All right, so now this is the first time we really had a du that has an x in it, a variable. If this variable x squared is not somewhere else in the problem, I can't add it in. All right, you could only add in constants. So for all the previous other problems, we just added 3, we added 6, they were constants. That's fine. Here, I have to have x squared somewhere in the problem. I don't have to have the 3 because I can add in a number. I just can't add in variables. All right, so I need to have all of this somewhere here. There's my dx, there's my 3x squared. If this x squared was not here, you couldn't do this problem. There was no way you can do this problem. We'd be done. Probably not going to have that happen to you. All right. So if this 3 wasn't here, that's fine. We could add in a 3 and then put a 1/3. But everything is here. So what I've just circled in orange, whatever color that is my what? That's my du. So I'm rewriting the integral in terms of u and du. So that's all gone. That's all gone. I don't need to put anything on the outside because all of it was already there. I didn't add anything in. What's left? Well, the fifth root of x cubed minus 1. Well, x cubed minus 1 is my u, so it's the fifth root of u, which I'm going to rewrite as u to the 1/5. All right. All right. So we have u to the 1/5 du. All right. And we're going to do the power rule. So that's u, add 1 to that is 6/5. I then take the reciprocal, so the 6 goes on the bottom, the 5 goes on top, and I replace my u. And so my final answer is 5 parentheses, what's my u? X cubed minus 1 to the 6/5 all over 6 plus c. All right. So that is our first day of substitution, integration by substitution. All right. I'm not going to give you any other assignment today. I want to make sure that hopefully you guys can go back over this. And if you're confused by something, we're going to do example 6, 8, and 9, and then tomorrow, and then we'll do some trig stuff. We'll get into it. And then after that, I'll give you a worksheet practicing all of this. Okay. But always can refer back to this notes to help you guys out. All right. So hope you guys all doing well, and I'll talk to you soon.